Welcome to Java tutorial. My name is Kishore. In the last video, we discussed about operators. In this video, we will discuss about a few more operators like decrement operator, ternary operator, and bitwise shift operators. Let me first create a new class and name it as test few more operators. I will create a main method. Firstly, decrement operator is represented with 2 minus, then ternary operator is going to be question mark colon, and then bitwise shift operators. There are three bitwise shift operators. One is right shift operator, which is also called as signed right shift operator, then signed left shift operator or bitwise left shift operator, and one more is unsigned right shift operator. Let us first discuss about this minus minus, which is a decrement operator. If I take a variable like a equals to 5, and in the next line if I create a variable b and mention a minus minus, this is called as a post decrement operation. In case of post decrement, what happens is the value will be used first and then the decrementation happens. It means the value of b should be 5. Later, once the assignment happens, the value of a will be decremented. So if I print the value of a and value of b, you should see the value of b is going to be, let me print here b, the value of b is going to be 5. However, the value of a will be decremented by 1, which is 4. So you can see a is 4 and b is 5. Let me apply int c is equals to minus minus a. This is called as pre-decrement operation. In case of pre-decrement operation, what happens is the decrementation happens first and then the value is going to be used. Currently, the value of a is 4. Why 4? Because it is already decremented by 1. So it means minus minus a is going to be 3, and the value of 3 is then assigned to c. Let us print a and see what is the output. It should be 3 and 3. Then let us use this ternary operator. So what are the values we have now? A value is 3, B value is 5, and C value is 3. Correct? Using these values, let us use the ternary operator. How does the ternary operator works is, it is going to apply a condition and then based on the condition, the result towards the right side of the expression will be stored. The syntax is something like this. Condition, question mark, value, colon, value. So if the condition is true, the value which comes after the question mark will be used. Else, the value which comes after the colon is going to be used. To understand that, let me write here int d is equals to a greater than b, question mark a, colon b. What is the meaning of this is, the value of a, which is 3, greater than the value of b, that is 5, means the value of d should be a value. The value of a should be assigned to d. If not, then the value of b should be assigned to d. So it means d value should be either 3 or 5 based on this condition. Because 3 greater than 5 condition is false, the value of b is going to be assigned to d. So what is the value of b? That is 5 will be the value of d. Let us print the value of a first and then b and then lastly d. And if you observe the output, a is 3, b is 5 and d value is 5. So this is how the ternary operator works. Coming to the bitwise shift operator, this greater than is called as bitwise right shift or signed bitwise right shift operator. Then we have less than, which is also called as signed bitwise left operator or left shift, correct? Then 3 greater than symbol, which is called as unsigned bitwise right shift. So there are these three right shift, left shift, and unsigned right shift operators. Let us take one value, let's say int x equals to 8. Suppose if I print the value of x like this, x 2 greater than symbol 2, what happens is it is going to shift the bits towards right side to two places. To understand that, we need to first convert this 8 to binary value. What is the binary value of 8? The binary value of 8 is 1000. Because x is of int, it will be 32 bits. Let us keep those 32 bits: 4, 8, 12, 16, 20, 24, 28, then 32. Because we are applying 8 right shift to 2 bits should be shifted towards right side. Means these 2 bits will be shifted towards right side. In that case, our result is going to be like this, where the 2 bits are going to be empty, the MSB. What will be the value that will be added to this MSB is, it is going to add based on the sign of the MSB. The sign of the MSB is 0, means it is positive. If it is negative, the MSB bit is going to be 1. Because it is a positive value, the right shift signed operator is going to apply 0 for these two empty bits. So when you convert this one to decimal, it is going to be 2. So 8 right shift 2 means, the meaning is divide the 8 value by 2 twice. So when you divide the value of 8 twice, first time it is going to become 4, second time it is going to become 2. So that is what the result of 8 right shift 2 positions. So this is going to be 2. So you can observe 2. Let me print the x value by shifting 2 bits towards left side. If you are shifting towards left side, how does it work is, let me again take these 32 bits. So this time what we are doing, we are telling 8 should be shifted towards left side with 2 bits. Means the binary value of 8 should be shifted towards left side 2 positions. So in that case, this 1 will be shifted towards left side 2 positions, means it should appear somewhere here. Let me copy this, and this 1 will be shifted here, and second time it will go here. And when it is shifted twice, obviously the two bits, the first bit and the second bit, should be empty. And what happens is, the value 0 is going to be added to those empty bits. So this is what the result of 8 less than 2. It means it has to multiply 8 by 2 twice, which is actually like this. So multiply 8 with 2 twice. In that case, what is the result is, 8 into 2 is 16. 16 into 2 is going to be 32. Let us see what is the value of x less than 2. We are expecting 32. So is it 32? Yes. The next operator we will discuss is this unsigned right shift operator. How does this unsigned right shift operator works is, it is going to convert even negative value also to positive. For example, if I have minus 8 and if I apply just right shift operator, what is going to be the value? First, we will observe that. Suppose I have y is equals to minus 8 and I will apply here y right shift 2 equals y right shift 2. Because I am using a right shift operator and also concatenating that expression, this is giving error telling that you cannot use this 2 greater than symbol is undefined of the arguments type string and int. What you have to do is you have to wrap these things telling that this should be treated as a single expression. So in that case, that error will disappear. Now, when y greater than 2 is used, the output is going to be minus 8 should be divided by 2 twice, means it is going to be minus 2. But you can observe minus 2 means negative value is still there, means that negative is still retained, means the right shift operator retains the sign. That is why it is called as signed. Even left shift operator also retains the sign of the value. But in case of unsigned bitwise right shift operator, the negative also will become positive. Let me apply this right shift unsigned bitwise operator, that is y 3 times greater than symbol 2, and what is the value is, let me first run the program and observe this is what the value it is showing. You might be thinking why it is showing this value, but you need to understand it is a positive value. The reason is very simple. Firstly, we will figure out the binary value of minus 8. So, for that, we can use one of the inbuilt class called integer class, which can convert a number to binary value using one static method called binary string method. That is two binary string method. If you don't understand what it is now, you can just ignore. But I want to just figure out what is the binary value of minus 8. So if I run this program, notice this is what the binary value of minus 8. So let me copy this minus 8 binary value here. And what we have done in the 23rd line is we have mentioned y value should use right shift bitwise operator, which is an unsigned bitwise right shift operator. So we are telling use unsigned right shift operator and shift two positions. So if that is what happens, then obviously these two bits will become empty. Let me copy this. So it is going to shift these zeros towards right side. The two bits means obviously we are going to get rid of this two bits, and this 1 0 appears in the second position and the 0 appears in the first position, and there will be two bits that will be left towards completely left side. And when there are two empty bits, the right shift unsigned right shift is going to add 0. It is going to add 0 because there were two empty bits. So because it is 0, it is treated as positive, and this is the binary value we have, and obviously this should be much greater value than 8. Because of that reason, it is giving this value 10737418822. But in case of just signed right shift, what would have had happened was it would have shifted this two bits towards right side, and there will be two empty bits. But what happens is because it is signed right shift, it is going to retain that sign, so it is going to add that one to those two empty bits. That is why -8 right shift operator with 2 gave me -2. However, the right shift unsigned bitwise operator gave me this positive value. So that is it about these operators. See you in the next video. Thank you so much.